Oh my God. All right, guys, let's start. Let's take a look. I think most of you guys are getting towards the bottom there. So this first problem, I mean, always try this first. Because either it's the only thing you can do, and then you're done, or it'll help you actually do the problem. So here, what's the biggest number that comes out of 15 and 30? 15. I can take how many x's out? 1. Now, if I did take just the 5 out, just because I heard that out there, it's okay. It's sort of like reducing a fraction and not doing it all on the first go. Then what do? You just do it again, right? So if I take a 5 out, I get 3x minus 6. But you see how there's still a... There's still a 3 that can come out. So if I take a 3 out, now there's 15 out there. If I take a 3 out, there would be an x there, minus 2. And of course, if you just take a 15x out from the beginning, that's where you end up anyway. Is that cool? So it's the same thing as reducing fractions. Just because it says reduce a fraction, it doesn't say do it in one step. I can do that problem in 1 step. Well, great. You win that weird game show. But here, if you have to, you take 2 steps. Who cares? That's why after you do one thing, you look at what you're left with and make sure it doesn't go any further. This guy, what's this guy all about? Again, what saves your ass is GCF. It comes out of both? A. It's great. And you're left with this. What's up with this dude? Nope. Because if you think it's x plus y, you're wrong because you would get a middle term. If you think it's x minus y, you're wrong because you get a middle term. It's not supposed to be a middle term, right? Why do difference in squares work? Because a minus allows them to be opposite signs, which would allow them to cancel. That's a plus. They're not allowed to be opposite signs. They couldn't cancel the way they'd have to. Prime. That piece is prime. The problem ain't prime because I took an A out. Bam. But I can't go any further because that's a sum of squares. I can't do shit with a sum of squares. Maybe?
So do we write like that? And then
That's done. Yeah, you circle it. Say I'm done. Okay, I really hope you guys, please let that make sense. Why does the difference in squares work? Because the minus allows them to be opposite signs, which allows them to cancel, which is why there is no middle term. That's a plus. If I try to factor, they could be opposite signs. They would never cancel, so that can't factor, period. At least not using real numbers, but we won't get any further there. What about this guy? Again, I seem to be hammering this idea of GCF. Right? These people skip that by and then screw themselves over. Yeah, 9 comes out, and M, N. So what's left here? 4, and the MN is gone. The 9's gone. MN, because I took one of each away. Oh crap, I'm right there. 9 MN, 4 minus MN. Phenomena. Alright, how are we doing there? Is that alright? Yes, sir.
Where do you get the 9 from?
Because 9 goes into both 36 and 9.
Oh, okay.
Yeah. Same place I got the 5 or the 15 from the first guy. Yeah. Yes, ma'am.
On number 2, did you say that you couldn't factor
This piece? No.
the...
Because if you think that this piece is x plus y, it can't be because you would get minus 2xy in the middle, and there's not supposed to be a plus 2xy.
Did you do x plus y minus y?
But then y times negative y would be negative y squared, and this has got to be plus y squared. That's exactly why I know I can't do anything, because a minus is what would make it work. There is no minus, nothing makes it work. So I stop. I like it. I just really wish everybody would understand that. Just keep saying that until more people do. We'll see. What about number 4? What tells you what to do here? GCF? I always love it when somebody's able to take an X out. What would you tell that person very quickly about why they cannot take an X out?
Not everybody has one.
Yeah, the last dude doesn't have an X. How the hell are you going to take an X out of it? It's going to freak them out. And they don't all have 5 either, so nothing comes out of everything. So then you say, how many terms are there? 4 terms. So what do you do when you see 4 terms? Group. So what comes out? First 2? X squared comes out. And then you're left with x minus 5. Yeah, negative 25. So that becomes positive x. And this becomes minus 5, so that these match up. That's one of the biggest mistakes students make, is they take a negative out, but they leave that as plus or something. It's going to have to change. When you take a negative out, it's got to change. And then the almost last step. I say almost last step because, of course, this is done. He just comes for the ride. What do you do with this guy? That one was so yummy. I hear you guys love that. And you could write this also, in case anybody's curious, you could write this as x minus 5 squared times x plus 5, because you got 2x minus 5. Multiply. Do you have to write like this? No. That's why I didn't circle it.
So you write them out.
Alright. What do we got there? Is everybody alright? Let's see.
So if you would have left it how you did before you did the whole box answer, would it be wrong? So
Oh, if you would have stopped here?
yeah.
It's the same thing as if I asked somebody to factor 18 completely. Factor it completely. And they say 2 times 9. If the instructions say factor completely, why is that not right? Because 9 can go further. Same thing here. Factor completely. That can go further. If you don't go further, you're going to lose points. That's why you do something, you look through real quick and see if anything else can go further to make sure you're done. All right. Yeah. All right, so this bad boy, same kind of idea, right? You might notice that things are a little out of order, but let's try the way they are. What comes out of here? 2 squared. And what comes out of these 2? Negative 3t. Yeah, t squared plus 7. So then you get the next step. Plus 7. Am I done? You're like, I don't know about you, Jeff, but I'm done, man. I was done before you gave me this thing. Why am I not done? Because this piece has a t that can come out, right? This is done. This is not 7 is not even a square, and this is a plus. This has got no chance. This guy, they both have a t, so I can take a t out. Now, I don't know if anybody noticed, you could have taken a t out from the beginning. I wanted to see if anybody would say, wait, you can take a t out. Nobody did. So I could have taken a t out from the beginning, or I take a t out at the end. Math doesn't care. It just says at some point you got to freaking get that t out. It's a stupid English tea time joke, and there's something I'm not going to touch. So if you take a t out, please understand, I'm taking a t out of this, so what would be left here then if I take a t out? 3 minus 3, and this t squared plus 7 is fine the way it is. Shoo-pow. So hopefully everybody at least got to hear. But you see now, you gotta look and say, can anything go further?
Okay. So you don't write the T next to the,
You could, but it's convention to put anything by itself out front, because it tends to get lost if I put it in the middle, or it looks like a plus sign or something freaky.
oh,
Right? It's sort of like that times T times that is the same as T times that times that. Who cares what order you multiply in? So any single thing I take out, I put out front. Okay. Oh, you guys like that one.
no.
Everybody got here, right? I mean, if you didn't get here, I'm really, really, really concerned. If you didn't do the last step, I'm only a little concerned.
Should be.
Because this is just a grouping problem. That should be relatively easy. The only thing you got to look out for anything is when you think you're done, just take a quick second and look through. Am I really done? Now this one is looks like it's going to be easy. There's one little thing, it's just a thing you don't normally consider. I need factors of
You need something that's going to multiply
6
add to 7.
and add to 7.
1 6.
So they're
Yeah, 1 and 6.
apart.
Anytime these two are 1 apart, if it's going to work, it's going to be 1 and this number. So 6 and 1 multiplied by 6 add to be 7, so it's x plus 6, x plus 1, or the other way around. If you did the whole split up the middle term thing, you eventually get here, but that's a lot of work you don't need. Since there's a 1 out front, I just need the two numbers that work and I'm done.
But you gotta show your work.
Yeah, dude, this is good enough work right there. So this one, I almost have to accept it if it's not much work. Your calculator won't do this for you anyway, so I can kind of trust that this would have come out of your own brain. Is that cool? What about this guy? This guy looks harder, but actually in a way it's easier because it's a little more standard. They got to multiply by negative 15, add to be negative 2. What does that? Negative 5 and 3. This is a 1 out here, so I'm done. X makes x squared. Minus 5 plus 3 makes negative 15. And it also makes negative 2 when I do that. Right? This would be negative 5x plus 3x, negative 2x. So everything checks. Okay. So real quick, just to show you something. So if I had, for example, x squared plus 8x plus, what do you got, Jeff? 12. Now, I always get somebody that does something like this. Is that right?
No.
I get x squared, don't I? And 3 times 4 is 12. But the reason we do that intermediate, that little step here that they multiply to be 12, add to be 8, is because these add to be 7, not 8. So this can't be this. This can't be the right answer because it doesn't multiply back out to be this. So that's the whole reason we do this. What would the answer be?
6 and 2.
Yeah, it should be 6 and 2 that I put there. So that not only does 12 come out, but so does 8. So I actually do get that number. I do get this number. Okay, maybe. Where are we at? Oh yeah, this one. Everybody's favorite. The first part of this looks like it's going to be a cubes, but the last part says no. And of course, what saves your ass so many times? If you're having any trouble with something, go to yourself, did I try GCF yet? I mean, that's, if you're like, how am I going to make this work? Did I try GCF yet? And what comes out? The 2 and x. So then you're left with 4x squared. And that now is really easy to identify as an algebra thing. Difference of squares, right? I don't so much need you to be able to identify them. This is not algebraic botany, but I need you to be able to do it. But this is a difference of squares, right? So the 2x comes for the ride. The one big mistake is people forget to bring that, but then your answer could never multiply to be this, because you're missing that part. So that part's done, but bring them for the ride. How do you break this dude up?
2x.
2x
Minus 5.
minus 5? 2x plus 5. Now I'm done. Again, if you don't do this last step, you will lose points.
I forgot the last time. Oops.
Now, in the homework, if you go from here to there, then I am concerned that you did not do that work. And don't, I love it when a student says, I did it, I just did another sheet of paper. I'm like, you should know me by now. The most important thing for me to see is the work, so don't even give me that. All right. What about number 9? Why does number 9 kind of suck?
You got this.
I'll let you run. I can hear in your tone already, like, you got all this shit going on. Yeah, go ahead, man.
You multiply 20 times.
Good. The first number is not a 1. There is no GCF to save me. So I got to use 20 and 3, and I get... I try to make this sort of... I don't know, some of you guys might have looked at 32 and said, well, that's going to be sucky, but 30 times... All right, just give it a 20 times 3 is 60. The other easy way to do 60 is 30 times 2. And what do 30 and 2 make? 32. And if you to make negative 32, they just both have to be negative. So negative 30, negative 2. They multiply to be 60, and they add to be negative 32. Now, what I hate is when people do that correctly, and then they don't know what to do with these numbers. They just kind of throw them. I get this answer. I get x minus 30, x minus 2. That doesn't make any damn sense. X times x is 20x squared. How the hell? So that's no good. What are you supposed to do with those numbers?
You're supposed to put them in the middle. They're replacement
Yeah, you replace the middle with them, right? So it'll be 20x squared is still there.
with the X.
And I don't have a choice. I got to put my negatives in. That minus 30x minus 2x plus 3. And then you just group, yeah. So what comes out of the first two here? 10x. So you're left with 2x minus 3. And what comes out of the next two is actually, negative 1. So then the signs change. 2x minus 3. And this is common.
2x minus
Yeah, so 2x minus 3.
10x.
10x minus 1. Sure.
I got the same thing, but I put like a 2 and a 3 in that one.
Oh, yeah, you switch the middle?
Yeah.
That's fine.
Okay.
That's perfect. Yes, sir.
So when you're done with when you're done with like figuring out the negative 30 and negative 2, you're completely always done with that middle number, like for good. So you can just go ahead and cross out negative 32.
Yeah, you're replacing it with something that this is still negative 32, ain't it?
Right. Yeah.
But I'm just rewriting it in a more useful form. So just pure math would go, what the hell are you doing? That's still negative 32. But then we're like, no, we put it in a better form. Now it's got 4 terms. I can use an easy way to do it. When it was 3 terms, it was difficult. We made it 4 terms, now it's relatively easy. Notice I said relatively just to cover my ass. And then finally this guy. Now let me tell you this. To be honest, I always forget this with this book. The book doesn't even have cubes in it. I don't know if you've noticed that yet. Anybody done the homework yet? So I'm gonna make cubes like an extra credit problem because it just isn't in the book, right? I'm gonna always still teach cubes to make it complete, but you guys should probably think that's good news because normally this is the one that students hate the most. But if you understand it, you're gonna get some bonus credit. Hell yeah! So let's try it out. How do I know it's cubes? Well, it's got 2 terms, and everything can be cut in 3. 64 is a weird number, isn't it? Because 64 is 8 squared, but it's also 4 cubes. So 64 could work in cubes or squares. Real quick, just because. So 64, that's actually, I want you to see, if I broke it all the way down, it would be 2 times 2 times 2 times 2 times 2 times 2. Good Lord. So see how it would be this times this? That's if I want to look at it as squares. Or I can look at it as 2 times 2 times 2 times 2 times 2 times 2. That would be 4 cubed. So what's the next number that would work that way? 3 times 3 times 3 times 3 times 3 times 3. I don't know if you guys see what I'm saying. That's the next number because then I can look at it as 27 squared, or I can look at it as 9 cubed. And then 4 times 4 times, no, just kidding. Will I be on the test? No. Just trying to show you some neat shit. So what do I do with these parts to get this started? Yeah, this will be 4x, 4x, 4x. This will be 3, 3, 3. Not the way I teach it. There is a whole other way you could change the process so you could work that in there, but it just, whenever you have to deal with negatives and remembering stuff about them, it gets more confusing. So to me, I teach it in a certain way where if it's a minus, I know that there's going to be a minus here, right? And what am I going to put in the little dude? Yeah, one of these 4x's, I like it. Good, I like it. So then this has to go, and this has to go. And then, of course, the middle term is going to be what sign? Positive. Why? Because the middle dude is the character from Pulp Fiction that cleans things up. He's a cleanup dude. He's got to be the opposite sign so he can actually cancel shit out. And then 3 times 4x. And don't ever spend any time trying to factor that. It won't. Unless there's a GCF you forgot. It looks like it should factor, doesn't it?
Yeah.
I like that. That averages out, so I don't know. But it won't. Okay. Last few here. So this is the first little thing you do with factoring. Now, the mistake people make here is they'll multiply it out and then they'll refactor. I'm like, good Lord, you've made that problem so long. It's already factored, and what's more important than that is it's already equal to 0. If this was equal to 7 or something, then you would have to remultiply it out, subtract the 7, and do all that shit, because it wasn't made equal to 0. So here, what can I say? What's got to be true? Either x minus 2 is 0, or 3x minus 4 is 0. So x is 2, or x is add 4 divided by 3. Alright, and then this one, what's the difference here? This just hasn't been factored yet. X squared is x times x. What multiplied to be negative 24 adds to be negative 10. Now this one's evil because you might think 4 and 6. But they have to be different signs, so yeah, it's going to be minus 12 plus 2. So either x is 12, or x is negative 2. Bam. Because you set each one of these equal to 0 and solve, you just subtract 12, subtract 2. If you plugged either one of these into the original, it would make the whole thing become 0. And finally, this dude, there's something specific that happens that throws people off, but every time we learn something new, it doesn't mean everything we learned before is shit. It doesn't mean that. It just means here's more stuff to know. Why did I do all this? Why did I factor this exactly? Why did I factor? Why did I have to factor it? I didn't say. I just said solve. So if you did this one correctly, why did you do it like this? Because there's that x squared term there, right? If that term wasn't there, I would just add 24 divided by 10 and be done with it. Right? So because that term is there, I can't get my x's together. Therefore, I have to have a different way to do it. Now, what happens in this one, you bring the 2x through. Where am I? Where am I? Right? And what happens to your x squared term? Cancels. So now I'm back to old school. Just get my x's together. Add 3x, I get 7x. Add 3, I get 8. Divide by 7, I get 8 sevenths. Done. I didn't have to do it the new way because the stuff canceled. The reason for the new way canceled. See, this is the thing, though. I mean, Solving equations isn't new now. It's just that I know how to solve more equations now. So if they look like they did before, then I can solve them the way they did before. So that's something else math students have trouble with. Now that we're in chapter 7, everything's different. No, that's impossible. It can never change. You can only learn more stuff. The stuff you already know can't change. That would be evil. Then students can hate math as much as they do. But the reason people hate it is because they don't understand. They think that's true, but that is so not true. It just kills me. Sorry, I'll stop now. All right. So, last thing for today. And this is going to be kind of quick because we don't do much with this last section anyway. And the bonus problem, maybe I'll talk about it. We'll see. Well, real quick, did anybody try the bonus problem? This is the difference of squares. So real quick, this is a bonus problem, so I'm not too concerned about it. How do I do difference of squares? I put one of these things here plus one of these things here times one of these things here minus one of these things here. Right? That times that is that squared. That times that is that squared. And then I can just bring the negative through, get my like terms together. Alright, I'm not going to dwell on that too much. That would be a bonus kind of question. So I get like 3x plus y plus 7 and 3x plus 11 minus 1.
I thought you had to like do the to cancel the squares.
But you can't. It's not an equation. There's nothing. I can't do something to both sides.
Oh, okay.
Yeah, there's no equation here. You wish you could cancel the squares. Yeah. All right. See people madly writing it down.
Yes.
Yeah. Why that would help you. Keep doing it more out of habit. All right. So I decided not to do this. It just was too much. You got to know this. Yeah, I've gone and forgotten it all. It would just be, it's unfortunate. I just decided there would be just so much extra stuff I'd have to teach you. That's not really a part of what you need to know for this class. To really show where this comes from. There's something called completing the square, if anybody's familiar with that. It's a method to solve equations, and you can use completing the square to solve this equation. And then actually you get this answer. But just to show you this in action, if I have this equation here, just to show you how this works. Now this is a total plug and shove now. This is already solved. I just got to plug stuff in. Can you factor this? If you can, you're way better than me. I can't factor that just looking at it with me. So I need help to figure out what the answer is. Are factors of 2 that add to be negative 7? No. Are there some? Yeah, there are some. There are. But they're really gross. Okay. So tell me this. Can somebody tell me what A, what B, what C? What are those given this? What is A? 1. What's B? Negative 7. What's C? 2. Now I just got to throw those in. That's the form of the answer for any coefficients that you have. So now I can just do x equals negative b, so negative 7, 7. Give or take, right, plus or minus. Negative 7 squared, 49, minus 4 times a times c, all over twice a. It's really just plug and shove. Because all the work went into going from this to this. Now you can just plug in what A, C, and B are for this specific problem. So then you get 7 plus or minus square root of 49 minus 8. Is that cool? 49 minus 8. So that'd be 41. And then I could just stop there. I got two answers there, don't I? 7 plus rad 41 over 2 and 7 minus rad 41 over 2. Alright, so this will take about 3 minutes. The little bit that we do with parabolas for this class. Remind me how to find the y-intercept for anything. Plug in 0 for what?
X.
Yeah, so this is true for anything, for any y equals function of x that I have, right? Y equals whatever. So if I had y equals 2x squared minus 7x plus 5, what's the x-intercept? What's the y-intercept? Yeah, because you make x 0, what do you get? 5. So it feels a lot like mx plus b. And it's not linear, is it? But it's the same reasoning. Everything else has an x in it. So when you make x 0, you're going to be left with the thing that doesn't have an x in it. So that's beautiful. If it's in this form, the last number is the y piece of the y-intercept. So what's the y-intercept? 0, 5. Key guess. Does anybody know if this parabola is going to be opening up or down? Why up? First number's positive. I love it. And that is related to slope in a way, right? I know you won't, but if you did take calculus, calculus would be the slopes of things that aren't linear. So you can actually prove that it is related to the slope, but if it's positive, it's going up. If it's negative, it's opening down. Cup up, cup down. Is that cool? So this would open up. It would be like this. And this one would open down because that's negative. I mean, that's really the only two things that we learn. One of them is old news, finding y-intercepts. Ooh. What's the y-intercept of this guy? -1. 0, -1. I like it. And open up or versus open down. You gotta love that shit. It's exactly related to the slope. So that's all we do in that last section. There's just a few problems that are assigned. Okay. That's plenty. That's pretty good. All right. So everybody got a practice test, right?
Yeah.